Let's go over AP Calculus topic 3.2, Implicit Differentiation. And we want to highlight the essential knowledge that the chain rule is the basis for implicit differentiation. Up to this point, we've expressed functions explicitly. For example, in y equals 3x squared minus 5, the variable y is explicitly written as a function of x. You can put a value for x, and the formula will explicitly tell you what y is. But what about an equation like this? We can't easily isolate y. This is called an implicit form. The relationship between x and y is implied by the equation, but y isn't given to us as a clean function of x. Here's the graph of that equation. As you can see, implicitly defined curves are not necessarily functions. They can violate the vertical line test, be broken up into several pieces, and even cross over itself. But for small pieces of the curve, y is a function of x, and there's a well-defined slope at nearly every point. And that's going to allow us to use our differentiation techniques, especially the chain rule. We can find the rate at which y changes as x changes, the slopes of tangent lines. So how do we find the derivative, dy dx, for an equation like this? We're going to use a method called implicit differentiation. Here's the core concept. We're always differentiating with respect to x. Let's see this in a few examples. Find the derivative with respect to x for this expression. Here the variables agree. We're differentiating an x term with respect to x. This is just a simple power rule. Bring the power down, subtract 1 from the exponent, and the answer is simply 3x squared. Nothing to that one. Now find the derivative with respect to x of y cubed. Notice here the variables disagree. We're differentiating a y term with respect to x. We must use a chain rule. The outside function is the cubic part. The derivative is 3y squared. The inside function is y. What's the derivative of y with respect to x? Well, we don't know what y is, so we just write it as dy dx, because y depends on x. So the derivative is 3y squared times dy dx. Try another one. Find the derivative with respect to x for this expression. We can differentiate this term by term. First, the derivative of x with respect to x. Well, that's just 1. Second, the derivative of 3y with respect to x. Again, the variables disagree, so we got to use the chain rule. The derivative of 3y is 3. Don't forget to multiply by the derivative of the inside, dy dx. So our answer is 1 plus 3 times dy dx. Last one. We have x multiplied by y squared. How do we differentiate the product of two functions? Hopefully you said the product rule, which goes as the first function times the derivative of the second function plus the second function times the derivative of the first function. Keep in mind this is all with respect to x. The derivative of y squared with respect to x, we're going to apply the chain rule. Take the derivative of something squared times the derivative of the inside, dy dx. Let's add that to the second function times the derivative of the first function, which is just 1. Clean this up, and there's our final answer. So don't forget, when you're finding dy dx implicitly, you have to realize that the differentiation is taking place with respect to x. You'll have to use the chain rule.